introduction to the project. Oh. So Fed4FIRE, I think most of you have already heard about us. We are an IP project in the FP7 framework, coordinated by iMind. We are at the moment with 28 partners, and we are we started in October 2012 and still have some further time to go. We have a budget of roughly 8 million euros. We started with a little less than the 28 partners of today. We started with 17 partners from day one. You can see them listed here. And then through the first open call mechanism of last year, we added these partners. And then, of course, you are all dialing in because you are interested in our second wave of open calls that's being active today. The project itself is all about federation of testbeds. So there are several testbeds out there in different domains of future internet, different technologies, different applications, and so on. And we try to bring this to the experimenter as a single federation over all these heterogeneous resources. Why do we do this? Well, we think it's valuable to both parties involved. So first of all, we think towards the experimenter that we have some benefits that we can offer, because as an experimenter, you can have all the testbeds easily accessible in one place. You can combine them in one experiment, which was a lot harder before. You have easy access to them. You are also, if new testbeds come up, you can learn about them through the federation, and so on and so on. The same goes towards the testbeds. Why would they join the federation? Well, they can have access to a much bigger user base, which is in the end the main reason for making testbeds is to have them being used. It's a way of promoting and advertising your testbed with a bigger impact. You can develop common tools and so on. So they are more part of the value offering, but in the end we think Fed4FIRE has value for both experimenters and testbeds. That's why we are having open calls for both parties, and we will introduce some aspects of the project for both parties today. To give you a quick overview of the facilities we have right now, so we have 17 testbeds with different technologies. So a first set of technology is Wi-Fi. So we have 4 Wi-Fi testbeds in our offering. 2 of them are in Greece, so Mythos and Netmode. One of them is here at iMind, the iLab-T, and one of them is in Sydney. The one in iMind is not only Wi-Fi, it's also a Zigbee testbed, so Internet of Things 802.15.4 technology. And the same kind of technology can also be found in the Smart Santander facility, which is a very well-known Internet of Things Smart Cities testbed. So you can also get the data of that testbed. Then another type of technology is cloud computing. So we have some cloud computing testbeds, which mainly come from the Bonfire project. So you have the Bonfire site of EPCC in Edinburgh and of Grid 5000 in France. And in Ghent you have our second testbed from iMind called the Virtual Wall, which is actually a testbed based on Emulab technology, which means you can emulate any kind of networking topology. But we use this to also act like a Bonfire site. A quite different type of technology is OpenFlow, which is also having a great momentum in research today. And we have several testbeds offering OpenFlow devices, mainly coming from the Ophelia project, but also from other places. So from Ophelia, we have the islands in Bristol and in Aitukat. Those are the 2 OpenFlow islands, the new ones. And then also the Virtual Wall also acts as an OpenFlow site. So this same testbed can also be considered as an OpenFlow testbed. We also have an OpenFlow testbed in Korea, Korean, which is also very nice because there it's really distributed across the country. So we have different kinds, while the others are more in a lab environment or in the city. Then in terms of LTE, we have 2 testbeds. One of them is focusing more on the core network, the evolved packet core. This is the Fuseco playground in Berlin. And then another one is more about the radio access network. This is the LTE Performance Lab in the University of Malaga. Then one of the other testbeds is very well known as Planet Lab Europe, which basically gives you virtual machines at your disposal spread geographically across Europe, and they are connected directly to the internet without firewalling and so on. So this gives you outlook points or vantage points on the internet across Europe. Then after the open call, we also received 2 new testbeds focusing on optical networking. So in Madrid, as you see here, they are doing the integration at the moment. And once this is finished, they will do the same for a testbed at Stanford University in the United States. And then there's another type of technology called community networking, which we all know from the multi-hop mesh networking based on Wi-Fi technology, but they also put cables in the ground, optical fiber, and you can also experiment with nodes on such a community network, which has very specific characteristics, and this is the UPC Community Lab testbed. So this is an overview of all the testbeds we currently have in the offering, and like I said, we are looking with the open calls to even broaden our offering. So where are we in the project today? Like I said, we started on October 1st, 2012. This means that we are about halfway of the active development phase. So we have 3 years of active development, and then 1 year of sustainability mode where we keep operational in an open access model, but there's a lot less development going on. Maybe some optimizations and bug fixing at the testbed, but that will be the main activity next to support. Okay, so that was the project from a very high level in a nutshell. Now I would like to dive a little bit deeper into the aspects, both for experimenters and for new facilities. So to start with the experimenters. What is the goal of what do we want you to allow you to do on these different testbeds that I just explained? Well, you have something we call the experiment lifecycle, and we want to support you in every step of that lifecycle. So as an experimenter, the typical steps that you go through are, first of all, you need to learn what are the resources out there. We call this resource discovery, and this is just learning what is available in Fed4FIRE. Now, once you have all this information, you want to match this with your specific needs. So, like an example for resource requirements, you might be looking at doing some Wi-Fi experiments with 802.11n technology. So you filter on to nodes that do allow to provide you this capability. So that's the second step, resource requirements. Once you have identified the appropriate resources for you, you will reserve them to do something on them. So that's the third step, resource reservation. Once the time of that reservation is there, then the testbed will make these resources ready for you. We call this provisioning. So they might flash this with a new image so that there's no software from previous experiments on it and so on, maybe with a specific operating system and so on. So this is resource provisioning. So that's the basics. So then you have access to resources at these testbeds at your disposal. But you might want to have more than basic access. If you have a lot of nodes and you want to test advanced experiment scenarios, you might want to control the behavior of your nodes in a more advanced way. We call it experiment control. You see an example here. After 10 seconds, you start a data stream, but then after some time, there's a second data stream. Then you can do some nodes down to see the resilience of the network and so on. So we call this experiment control, and we also want to provide you tools to make this easier. Of course, we all do experiments to learn something, so we have to monitor and measure what's going on. And we define 3 types of monitoring, basically. The first one is called facility monitoring. This is high-level health information. So this gives you an idea, is the testbed up and running or not. The second type is infrastructure monitoring. This is more detailed, and this gives you an idea of what was going on during the execution of your experiment. For instance, if you have a virtual machine, you might want to know if the physical host on which your machine was running was overloaded in terms of CPU, RAM, and so on. This is typically information you cannot access yourself because you only have access to the virtual machine in this example, but the federation will make sure to offer you this information anyway. And then the third one is the classical measurement you do yourself. So for your experiment, you define some metrics that will help you prove the case you are testing, and then you can just measure these things yourself. An additional aspect is, of course, storage of these measurements so that you can analyze what happened later on when you are writing your paper or deriving your conclusions. And then the last part of the experiment is when you're done, you release them so that anyone else can start using them. So those are the different steps we want to support you in. And how do we do that? The full architecture, all the details are coming next in the part for the testbed providers, because for those it's interesting to know what we expect from you to deploy at your testbed when you become a Fed4FIRE testbed. But for now, I'm focusing on the experimenter side, so I'll do a little bit more abstraction. So if you just start from the fact that there is a testbed out there with a specific resource, a Linux box or whatever, and like I said, there are different steps in the life cycle. So the first big block of steps were the one on the top, which was discovering resources, reserving them, and getting them provisioned for you with basic access. To do this, there is one API which all testbeds have to support, and this is typical for our entire architecture, that we work with open APIs, and then the testbeds, they can do underneath whatever they want as long as they support these APIs. And you, as an experimenter, you can use any experimental tool that you like which supports these APIs. So that's very interesting, because we have very heterogeneous resources, and some tools might be more suitable for certain technologies than others in the way they visualize them and so on. Also, maybe some people prefer graphical user interfaces, while others really like to script things and work text-based. So we don't limit, we don't say you can only use this and this tool. We only make mandatory the APIs, and then the tools are just free to use. Today, which tools are out there that support this as a V interface in this part of the functionalities? Well, we have a portal that we are developing, which is based on the MySlice tool. We also have a new tool coming out of the project called JFET, which Stace will demonstrate you in a minute. And then there are some tools which existed before the project called SFI and Omni, which are more command-line tools, and FLUC, which is also a graphical user interface from the United States. So this is important to know. As an experimenter, there's a whole set of tools, and you can just play with them and choose the one you like most. The security in these tools is done through typical X509 certificates. So that's something you will need an identity, you will need such a certificate, and you will need to import this in your tool. But then you can use any tool you want. The second big block of functionality was that experiment control, so the execution of those more advanced scenarios. Well, for those, we need something at the resource on the bottom, which can perform commands on your behalf. We call this the resource controller, and it's just, you can send commands to it to do certain shell function calls for you. And there are, we defined again the API on top of that. This is called FRCP. And then you can again use any tool you want. At the moment, there are two tools that are mature enough to use. The first one is called OMF. OMF6 is the latest version of that. And the second one is called NiPi. So again, you can choose which one to use. Next to that, we, as much as possible, I think on almost all resources, we also provide direct SSH login to the nodes, because especially before going to advanced scenarios, this is a good way to start playing around with the resource and learn about its capabilities. And then the third big block of functionality is about measurements and monitoring. There we have defined that the data will always be exported as something called an OML stream, which means you can use any OML client that you like. So you can, on those streams, there are filters that you can easily configure. You can store the data in an SQL database, or you can visualize them live. So those are the kind of tools you can use. And then we, like I said, we have different types of data. So we have a monitoring library, which was the data like in the VM case of the physical host that you can't get yourself. And there's the measurement data also that can be used coming from different frameworks. So this is in a nutshell the experimenter side. So to recapitulate, there are three big blocks of functionality, being the basic steps to acquire the resources, then the more advanced control, and then the monitoring and the measurements. There are three different APIs defined for that, and then you can use any tool which supports these APIs. Now, in the next part, my colleague Thijs will show you this first part of functionality, getting the resources using JFET. Like you can see on the slides, these tutorials, you can find them yourself also online. So if you want to do this later on, you can. In preparation of your possible proposal, or just to know what you could do on the federation. And if you want to learn more, if you want to have real hands-on experience, I would invite you to an event we are organizing, which is called the first Fed4FIRE Genie Research Experiment Summit. Informally, we call it the Summer School, and it's basically a great opportunity for you to. There will be a week-long lessons and so on here in Ghent in the second week of July, starting on July 7th, where we will train you and we will guide you with working with these kinds of tools. But that's just for your information. So if you want to learn more, the link is here. You can also you can just go to our website of the project and go to events, and you can also find it. So that's very interesting. Okay, so Thijs, I will make you the presenter now, and then you can give this demo of how to do a simple experiment on Fed4FIRE.
Okay, good morning. I'm Thijs. I will give you a short demonstration of what JFET is and how you can use it. For that, I will just show you around in the GUI, after which I will perform a simple experiment, and I will conclude by showing you some nice advanced features that are integrated in JFET. Okay, you can find JFET on our website, jfet.imines.be, and when you click the Quick Start button, our Java tool is started via Java Web Start. As you can see here, my user certificate is loaded, and after entering the password to this certificate, I am logged into the main experimenter GUI. Let me first show you the preference dialog. As you can see here, it has PuTTY integration, so I have to select the location of my PuTTY installation directory. Normally this is detected by default. JFET is also able to use Pagent, which is part of PuTTY, which automatically manages my SSH keys. For the rest, I can choose for authenticating on the nodes of my experiment. I can choose to use the certificates or the private key that is also embedded in the certificate file, or can specify my own PuTTY private key. For now, I will just choose a simple option of using private key that is embedded in my certificate. And then you can see we also have integrated proxy support in JFET. This is primarily meant to make it easier for you to get past corporate firewalls and so on. Another use case for the proxy is IPv6 access. Some testbeds only have public IPv6 addresses because of shortage of IPv4 addresses. And by using the proxy, you will automatically be able to get access to those IPv6 only nodes. Okay, that's with references. Now I will show you how to perform a simple experiment. I've clicked New Experiment Definition, and now I have a canvas here in which I can just drag and drop nodes that I want to use. A let's say, for example, that I want to do a simple experiment with a client and with a server. I've put in 2 nodes in the canvas. After pressing configure node, I can change the name. I can also select on which testbed I want to execute the experiment. You can see I can choose it from Bonfire, Planet Lab Europe, the virtual wall, the Y Lab, and so on. For now, I will just stay on the virtual wall here at iMind. I can also choose which node I want to use. After clicking on specific nodes, JFET will query the testbeds to get an overview of all available nodes for the moment. This is especially important, for example, in a wireless testbed where you always want to know which node you are using. But here at the virtual wall, it doesn't really matter because they are all the same and interconnected. So I will just choose any available node. Okay, I will also change the name of node 1 to server. After that, I can just add a dedicated link between this client and server. This link can be configured. I can add capacity, latency, packet loss, and so on. This is EmuLab specific, but can be very interesting for performing experiments on a wire testbed. Okay, I've designed my simple experiment. Now I just press run. I give it a name. And I press OK. Now you can see that JFET starts with registering the experiment, contacting the testbeds involved, and so on. Because I've selected the virtual wall, I know that it will only take 3 to 4 minutes before my experiment will become available. In the meanwhile, I can show you what is going on more specific. Here I've pressed the Advanced View button, and here I can get an overview of all the calls that have been made to the testbed and how what the result of it was. For example, here when I select Create Slides, I can get an overview of all the calls that were made. So I see, for example, first a register call was made, and I can get an overview of all the information that was sent and that was received. Normally, you don't need to interpret all this, but when things go south, this can be very interesting to understand what is going wrong.
Oh my God.
Okay. While we're still waiting for this experiment to come online, okay, it's here. So now you've seen that the experiment has become green, the nodes have become green. JFET has also performed a connectivity test to these nodes to verify that they are indeed available to me. And now, to get access to these nodes, it's as simple as right-clicking on them and pressing Open SSH terminal. After pressing this warning, I am automatically authenticated and I can start with doing my experiment. Okay, this was the very simple version. When you want to do more advanced experiments, you have the opportunity to go to the raw RSpec. Then you get to see what is sent to the testbeds, and you have the possibility to edit and add anything you want. Of course, you have to know what to add, and for that we have a very good documentation website. When you click here on testbeds, you get an overview of all the testbeds, and you can click through to the testbed specific documentation. When I do this for the virtual wall, for instance, I get an overview of all the specific things that I can do. For example, if I want to install a specific disk image on a node, I get the documentation of how I can do this. And here you see, for example, which extra tag that has to be added to this RSpec to be able to select the disk image that I want. The same is true, for example, for performing OpenFlow experiments. Then it's also as easy as just adding some tags in the RSpec, and you can get started on your experiment. Further on, here in the experiment view, you also have the opportunity to go to the raw RSpec, which gives you more detailed information about, for example, the host name of each of your nodes. And also you get insight in the manifest RSpec that has been returned by the testbed. In this manifest RSpec, for example, you have extra information on the MAC addresses of each of the interfaces and so on. For example, here you see the MAC address, here you see the IP address that has been assigned to these nodes and so on. Other interesting things that you can do with JFET. Now I have a simple client server setup, but if, for example, if I want to do more advanced tests, for example, I want to add impairment to this link, I can choose to add an impairment bridge. This will add an extra node in the background which will be dedicated to doing this impairment. You can add latency, you can restrict the capacity of the link, you can introduce packet loss, and so on. You can also choose to do it only on one side of the link, and so on. Okay, I think this was a basic introduction into JFET. I will return the word to Wim.
Okay, thank you, Dave. I hope it's clear that this is one of the tools. Like I said, there are more that you will be able to use in the future. But one of the tools that tries to abstract as many underlying details to you as an experimenter as possible to make it very easy to start working on the short term with the resources. But once you need more control, more details, that we do allow you this flexibility through the raw editing mode in combination with documentation to really be able to use the strength of every specific testbed using the same tool. So I think this is something very valuable for us as a federation with so many resources. Before I continue, because the next part is about more the testbed side, maybe there's time for questions now about this one, about the experiment side. And then we can continue, I think, 10 more minutes with a bit more details which are interesting for facility providers. So please, everyone, don't be shy. If you have a question, now is the time to ask it. Just make sure to unmute yourself or we can't hear you.
Hi, this is Valeria from Fraunhofer. I wasn't sure what Fed4FIRE was about, so I'm also just curious about the collaboration, and it looks to me as if you are more about trying to put in latencies and stuff like this, but not so much, for example, about this Internet of Things that you could provide data and one could read data, for example, from the Smart Rotunda testbed. Is that correct?
Well, that's true. That's the tool you saw now is indeed more about networking and so on, and a bit less about data and services. That's entirely true. And this is something we noticed during our first development cycle. So I showed you very quickly that we have 3 years of active development, and this, I didn't go into that detail, but this is actually broken down in 3 different development cycles. And indeed, we saw that in the first cycle, things like you mentioned, getting data out of Smart Santander, are not that well supported using tools like this. For this, we have extended our architecture. This will come down in a minute. With we call them application services, and there the APIs are a bit less stringently defined because it's harder to say what a service will do. But we allow this. So this means in the concrete case of Smart Santander that there is some REST interface at Smart Santander that you can access as a Fed4FIRE user to retrieve the data. Of course, you have to know all this, and for this we have added something we call the application service directory. So we allow testbeds to also work on this level. We harmonize it a bit less, but what we do harmonize is the information you can find about their existence. So, and then it's, in that case, it's more just an API that you call from within your own software to retrieve the data.
Okay, but here's Valeria again. Then one would need to know more details about the census and what is out there. I guess that there's some documentation. Yeah.
So on the documentation page that they've just shown you, there is typically there is for every testbed 1 or 2 paragraphs showing you very static, high-level information, and then we always expect a link to more details of the testbed. So Thijs is now showing you the details of YLabT, for instance, in which, in this case, you want to know the location of the testbeds while it's added in the documentation. I have to check for Smart Santander. I'm not sure what level of detail they are giving at the moment, but this is all still a work in progress. But that's the intention. So indeed, for Smart Santander, you will also have different mechanisms to know which are the sensors, where are they located, is it CO2, is it noise, is it temperature, and so on. And then, because you need this, of course, to make use of that REST interface. Yeah.
Hi, Wim. This is Johan from CTVR, from Trinity College. And regarding the proposal, I'm wondering about the following. As potential partners, as the rest of the people who's attending this meeting, I guess they are willing to provide their facilities to Fed4FIRE, but I believe it's not only about providing facility, but also deploying our own APIs. So, for instance, in the previous question, she was wondering about something very particular to a testbed. And in the JFET tool, for instance, the example was targeting something particular to iMine testbed. So based on this question, I believe any provider, any future provider of facility should also deploy an API that tackles the particularities of their testbed.
Yeah, well, it's the Smart Santander testbed was a quite specific case because there the resources are very restrained in their capabilities, and they are quite different. If I am very roughly speaking, very blunt or hard to say, in many cases the testbed resources are, you can consider them to be Linux boxes with very specific hardware inside of them, and then in those cases, the SFA API, which is used by JFET underneath, is quite suitable. It is an API which is already being under development even before Fed4FIRE and other projects, and even outside of Europe, for federation of testbeds. And it's quite suitable because it's very extensible. In that XML format that Thijs has shown you, you can give a lot of information of what kind of resource you want and how you want to configure it. So the basics are the same. But then indeed, to get all the specificalities out of it, you don't need a different API, but you need different XML files within that API. And that's why we want to support this raw editing mode. And of course, what's very, in our approach, you can always have a testbed offer additional APIs, as long as you also offer the Fed4FIRE APIs. That's very important for us. So you don't get absorbed by the by the Federation. It's just if you support the APIs we ask you to, then you can become a part of it, but you can also do your own things. You can expose 100 different APIs, and then you can put it on your documentation page and so on. But to be also uniform towards the set of tools for the experimenters to make it easy to use the basics of your testbed, we have this set of 3 APIs being SFA, FRCP, and OML.
Okay, thank you.
You're welcome. Any other questions?
Hi, this is Walter Coliti speaking from Incision. I have 2 questions. First one is how are all the testbeds available for the call? And the second one is are we supposed to be familiar with the experimentation tools? I mean, should we show that we know JFET or these tools that would be used for the experiment?
Okay, those are good questions. The experimenter, the testbeds, like you saw, they are not yet all available in JFET at the moment, but they are usable then, or they will. How to say it differently? At the moment, in the first wave of open calls, you see that you can't all use them in JFET, but we have alternatives in the case you can't. So then there are some workarounds, and you can use them. They are all available. By the time the second open call will start, which will only be the end of 2014, situation will be improved a lot more even. So then the integration in JFET will have advanced a lot further. But so you don't have to, you can consider them all being available, although they were not in JFET in the demo of today. Yeah. And then the second question was about, could you remind me? I've lost
if we are supposed to know these tools, like should we show in the proposal that we are familiar with JFET?
You don't have to. It's not a bad thing to know them, of course. You don't have to really know how you can use them, but I think you have to prove that you are willing to use them, so that you are aware of the fact that we have a portal in the making, that JFET is existing, that you can do experiment control using OMF or NIPI, and so that one slide where I gave you the 3 blocks of tools, that you are aware of them and that you will use them. So because in the end, if you look at it from our side, why are we paying the experiments? To get feedback about how usable our tools are. So if you, for instance, to do an advanced experiment run where a lot of things happen and you use your own kinds of scripting tools to do this, then we can't learn if NIPI or OMF are good experiment control tools. So you should be aware of the different tools in our offering, and you should illustrate or say in your proposal or commit, that's the correct word. You should commit to trying to use them and to providing feedback about them. That's the most important thing. You don't have to know how JFET works internally exactly, although it doesn't harm you to know the high-level details, like that JFET is a graphical user interface, while OMF is a more scripting-based tool for experiment control. You have to know them on that level to be able to commit to using them. Yeah.
Okay, thank you.
You're welcome. Anyone else? Okay. In that case, I will continue very briefly with the facility point of view, and then we will end again with some Q&A. So there will be. Oh, there's an echo now. Okay. So I'll know who is. If you're not speaking, please mute. Okay. So. I'll continue now with the facilities, and then we do a last set of questions. So if you have experimental questions, of course, you can still ask them at the end also. Okay. So thank you, Thijs, for giving me back the presenter token. So, so this was the last slide before the demo. So once again, I really invite you, if you want to have really hands-on training for a few days or even a week, if you would like. You can come to you can register for the summer school. The intention of that is that once you've completed that you are really able to use Fed4FIRE in your own work. Okay, the testbed provider part. For this, I'll just go you briefly through the architecture, the high-level architecture of the project, and then for every aspect of that architecture, illustrate what we expect from you as a testbed. The architecture itself is divided in several different pictures, because otherwise in one picture it would become just too big. So the first picture is about the functionalities, the first functionalities again, discovery, reservation, and provisioning. So, like Thijs has shown you in the demo, for this kind of functionality, you typically do the following steps. You want to learn, you want to browse what's available in Fed4FIRE in some catalogs, being both the facilities and then these application services that I explained before. You want to register for an account and receive your certificates. You want to import them in your tools. And then you want to use those tools to connect directly to the testbed, to list the resources out there and to reserve them and get them provisioned. So that's what we want to support. Now the question is, what components do we need to do this? Well, we start with the very basics. So we assume you have a testbed with a resource. In this example, it's in this case, it's typically something which also has an SSH service running on it. So like I said, any Linux box, which is the majority of our resources. Typically, a testbed is managed by its own management software. We call this the aggregate manager. We don't care how you do this internally. Most testbeds already have their management software, and we don't ask you to replace it. This would be a tremendous amount of work. No, we only ask you to put an API on top of it to expose its functionalities. This is the aggregate manager API coming from SFA. So that API. And then, like I explained before, for some resources, you want to abstract them a bit more, like in the Smart Santander case, you just want to give the data. Or another example would be, I explained Planet Lab has machines all over Europe. You could create an application service which just gives you the ping time between two regions in Europe. So you give it 2 cities, for instance, and then the service would, behind the currents, require or reserve the correct VMs, provision them, do a ping, and give you only the results. So that's an example of an application service. It uses our resources, but it abstracts them from the user, from the experiment. Okay, so those are the things we offer. To learn about them, we have the documentation center. So you just browse to it, like Thijs has shown you, and this is one component of our architecture. Similarly, we have a directory for all the services out there. This is also documentation. So you learn. The next step is you want to register, because you have learned that Fed4FIRE is something good for you. You want to register. Well, you go to our portal and you register as the member authority of the federator. So this is something we as a project provide you as Fed4FIRE. A testbed can also optionally, so this is important, everything with light color is optionally, everything darker gray is mandatory. Optionally, you can have your own member authority. What does this mean? If you are a testbed and you have your own local user base, if they are managed by some authority, you can just add that authority to the federation, and as a result, all your existing users can also use the entire Fed4FIRE. So they don't have to register again for a central account. They just use the account of your testbed that they already have. But you don't have to do that. If you just say, it's too much burden for me, I will redirect them to the central one and let them create this one additional account. That's also very well. Okay, so now we have all the blocks to have people register for an account. Then we have different standalone tools, like we discussed before, where you will import your credentials and you can work with the testbeds. Okay. Then the next step is for a tool to get resources at a testbed. You need something called a slice. I won't go into most details, but a slice, you can consider this as a shopping cart, which you bring to every testbed, and then it puts the resources in your shopping cart. So that's the basic concept of a slice. And for that, you need very similar to a member authority, which gives you an ID. You need something that gives you a slice. We call this a slice authority. This is, again, we provide one as a federation for you, a centralized one. You can also run your own if you want. Okay, so now you have all the things you need to go to the testbed. You have your identity, you have your slice. But where can you find the testbed? This is, for this we have an additional directory service called the Aggregate Manager Directory, which is just a phone book. It gives you a list of testbeds and the coordinates, the contact information of the aggregate manager of every of those testbeds. So then your tool knows how to talk to this block, basically, and then it can ask for resources, it can reserve them, and it can get them provisioned. So there's a direct interaction between the tools and the testbeds. If you want, we also have a brokering service at the Federation. This can look for resources for you. So if you don't know exactly on which testbed, if you just want 5 VMs with a certain type of operating system, but you don't care on which testbed they are hosted, you can always ask the broker, because he has knowledge about which testbeds are having a lot of free resources and which not, and it will find the best testbed for you. So that's a broker service at the central federated part. Yeah. So that's the basic architecture for the basic functionality. If we zoom in on what the testbed has to provide, so on this swim lane, well, the only thing you really need is you have to make sure that your local management software of your testbed is exposed through this SFA Aggregate Manager API. That's the only thing. The other things are nice, but you don't have to do them. So if you don't want to deploy authorities that can provide IDs and slices, then you just rely on the central one. So you don't have to do that, but you can. If you want to provide an additional service, please feel free to do so, but it's not mandatory. So that's important to know. You need your own testbed management software, and you need them to support this Aggregate Manager API. For doing so, there are tools out there. The most well-known is called SFA Wrap, which is a wrapper you can use to add this exposure. So it's basically an implementation of the SFA side, and then towards your testbed, it has empty hooks where you can fill in the appropriate calls to your own management software. So there are some tools out there that can make it easier for you to adapt your current testbed management software. Okay, so that was it for the first figure. Then experiment control. What do you want to do there? Well, you want to first of all get some information about who has reserved which resources to make sure that you can secure them. Then you want to have scenarios which describe what has to happen in the course of your experiment, what nodes should do what. You want to translate this to messages which are sent to the different resource controllers, which are authorized, approved, and performed. So this is in a nutshell what has to happen. How do we provide this? Well, first of all, you need to have some tools in which you can create a scenario. We call this a scenario editor. And then the scenario has to be given to something which performs it. We call this experiment controller. So this is a component which will take this scenario and break it apart into all the different commands it has to send at the appropriate time. To who will it send these commands? To the resource controller at the node. So basically you can see this as a piece of software that you can ask to perform anything on your behalf that you would do on the command line yourself. So it's very flexible. And this is basically the receiving side of this experiment controller. The communication itself is being done over a publish-subscribe system called XMPP. And of course, like I said, you want to be sure that not anyone can control the resource, that it's secured. So we have an additional component called the policy decision point, which need information from your aggregate manager. One thing you can do is, if you want to make it, this is done quite often with OMF, if you want to make it easier for your experimenters to do experiment control, you can, instead of having them run their own tool, you can run one at your testbed and they'll just log into yours, to your deployment of that same tool. But this is not mandatory. Okay. So that's basically all the things you need. So if we zoom in again on the testbed swim lane, what is mandatory? the aggregate manager was already mandatory from before, so this remains. And then the thing you need to do is you need to have a resource controller deployed by default on your nodes, which support FRCP. The most known reference implementation of such a resource controller is the OMF6 one. Very practically, this is in most cases a matter of doing an apt-get install. Then it's available on the node. You make sure it's configured correctly after that, and then you make sure it becomes part of the default image of your nodes. So that's typically what you have to do. Then to support the communication, you need an XMPP server. You don't need your own, but typically for performance it's better. You can rely on someone else's XMPP server because it's very similar to a mail server. So you could use someone else's mail server if they allow you to do so. But for performance, it's better to have your own. But this is a matter of installing some open source software on a VM or a physical server at your testbed. It's also not mandatory, but we would advise you to deploy the policy decision point, because otherwise your resource controller is not secured, and then anyone knowing the communication channel being used in the pub/sub system can actually control your resource. So this is something to be avoided. So we do advise, although we don't oblige, to use the PDP. And then this is also, like I said, something optional. So in the end, this is what you have to do to support experiment control. And then the third part of the basic functionalities are monitoring and measurement. Like I said, we have three types of measuring. We have the facility monitoring, which is health status information. So we have a dashboard which gives you, for every testbed in our federation, you can browse to that website and you can see live if every testbed is up and running or having some problems or is partially down and so on. So for this, we need facility monitoring information, which will be used to create that dashboard view. Then the second type of information was infrastructure monitoring. So that was the example of the virtual machine where you get information about the physical host. And the third one is an experimenter that collects its own data, its own measurements. We also want you, if your data is stored at many places, to have a broker that can collect it for you and combine it, some storage and so on. So if I talk you through the different components, we get the following. The first type, facility monitoring. For this, the testbed management deploys its own tools as it sees fit. This typically is done through some existing monitoring tools like Zabbix or Nagios and so on. As long as you expose it as an OML stream to the central OML server. This server will then store it in a database that the first level support dashboard can use. So this is the dashboard, which gives you red and green status of every testbed. And it's also, the same information is also being used for nightly logging tests. So this is important. As a testbed, we will first, when you enter the federation, we will check manually if you have done the implementation of our APIs correctly. So we do a full compliance check. But after that, we continue doing so every night automatically. So this is important to ensure the quality of our federation. We continuously keep track of the fact that the APIs are supported well or not. So this is the nightly login testing. The second type of data was the infrastructure monitoring. We also let the testbed collect this as it sees fit, typically using the same tools like Zabbix or Nagios. And this is exposed to the experimenter itself, typically. And also for some other services, a subset of that is going centrally. But typically, for infrastructure monitoring, you say as an experimenter, provide me this and that kind of information during the course of my experiment. It will be collected by this component and will be pushed to any endpoint under the control of the experimenter. And then the third part was the measurement of your own data just while using the resources. As an OML stream, for this you provide some libraries on the nodes so that it's very easy to do so. What does this mean in practice? In your experiment code, you just write one or two lines saying dump my data, and you don't have to care about connecting to a database, about creating a table that corresponds with your experiment ID and so on. This is all done for you through this OML. And then, of course, you have to push this data at the moment to your own OML server. So there's no, that is important, there is no central server to store or to collect all the experiment measurements, because we expect that this will become such a huge amount of data that it's not feasible at the moment to support this. So you can get your data out of it, but you have to store it yourself. We do have a data brokering service that if you have several of those endpoints and there is some other data floating around, that you can collect this all through a single broker. And testbeds can also, if they want, provide some components themselves to do storage for the experimenters, but this is not obliged. So we don't do it centrally. We expect this to be done by the experimenter. But if you are a testbed who wants to make life easier for the experimenter, you can also offer this as an optional component. But it's at all not obliged. Okay, so that's basically the most important aspect of measuring. So again, as a testbed, what do you have to do? You have to get this high-level health information and the more detailed information about what's going on your resources. You have to collect this from doing any way you want, as long as you export it as an OML stream. And you have to make sure that on your resources, that those libraries, those OML libraries, are included in the default image. So this is also a matter of some apt-get install, and then you can offer them. There are some optional things, like I said, you can provide a storage service, but you don't have to, and you can even expose that storage as a application service. That's something they can call through a REST interface and so on. But again, you don't have to do this, but you can. Okay. So now I've talked about the three core functionalities that we have been discussing this entire webinar. There's one piece of extensions of our second cycle that I briefly want to touch. This is about service level agreements and reputation, but I'll go very quickly. So service levels means that we are exploring the possibility that you as a testbed can say to an experimenter, well, I provide you this and this kind of guarantees. For instance, about availability or uptime of the resources and so on. For this, we have something called the SLA management module. So this runs at your testbed, and this collects a lot of information. So it can collect these different monitoring types of information. It also is informed about who reserved which resources when, about who is using them, and so on. And it uses all this information to derive, has the specific SLA that this testbed offers to its experimenters been met or not. To make it very clear, we don't oblige our testbeds to support SLA. So this is in fact, while explaining this, something, an error in this annotation. The entire SLA is at this moment still, we are exploring it, it's not mandatory. And even if you do support an SLA, you can choose which one. So at iMinds, for instance, we are looking at uptime of the resources for a certain percent. You can define any other kind you want. In a wireless testbed, you could, for instance, define as an SLA that you guarantee that there's no wireless, that the wireless interference is below a certain threshold or whatever. So you have the freedom to choose it, but we provide you the basic building blocks to then derive if you have met it and to communicate this to the experimenter. So how do we communicate this? Well, we have a central component called the SLA collector, which at every testbed collects information about has the SLA been met or not. This is important because in a multi-testbed experiment, you need to know this for every piece of the chain or of the experiment. So we have this one collector, and then through the portal, you can get a visualization easily of the conclusions that the collector has made. Well, so this was SLAs. Then the second part is reputation. You can compare this to the typical review functionalities on any on any web store or hotel broker or whatever. So what we want to achieve is that if you are a testbed which has good stable nodes, which has good support maybe, and so on, if you provide a good experience to your experimenter, that you automatically get a better reputation so that you can attract more users because you are a high quality testbed, let me say it like that. So this is the main idea about the reputation engine. How do we implement this? Well, first of all, we expose some of that monitoring information from before to the central OML server of the federation so that this reputation engine can use it later on. So here it is, the reputation engine. It will use this data. It might use it through the data broker to make its life a bit easier. And then it will calculate, given some algorithms that we are exploring right now, it will calculate an appropriate reputation. It's important to know that this reputation will be a combination of these measurements and also automatic experimenter service on the portal. So they will also be a human part in calculating the reputation. Okay, like I said, these are functionalities which we are exploring more, so this would not be expected at the moment as a mandatory item for all the new testbeds. But if you do want to support it, if you think, well, SLAs, for instance, is something that we really want to work with, then this is what you would need. You would need this SLA management module, which is being developed by the project. You don't have to develop that for you. And then you would need to make sure that the other blocks you already had, and the monitoring blocks and the aggregate manager, are correctly giving input to that module. And then the SLA collector that we also provide will be able to talk to you, and the experimenters will be able to see this at the portal. So basically, you only need to deploy this module that we are implementing. And for the reputation engine, you just have to expose some of your streams to the central service, and that's it. Voilà. So that was the introduction for the facility provider part. So you can see here there are some ways to contact us. So we have our website, we have the contact email address. Thijs, who has just given the JFET demo, will also be present at AUCNC in Bologna in June, where he will have a demo booth and also some presentations. So you can always talk to him if you have any more questions. But of course, we are together now today, so I'd like to end this call with an additional round of questions if you have any. So please feel free to ask your questions now. Okay, if not,
may I? I'm Francesca Matarese from SESM Italy. I would like to make a question regarding the IPR management, regarding the application, industrial application that it is possible to install in the federation. I mean, is there a sort of IPR protocol that will be signed between the companies and the consortium or iMinds in order to manage the IPR regarding the industrial application that will be used for the test?
Mm-hmm. Okay. Well, in the first phase, when you write the proposal, you have the option to restrict the proposal itself to only RESCOM and iMinds, because we are coordinating the open call analysis. Of course, once your proposal would be accepted, then it will be better known by all our consortium members. So then I would have to check how this is protected. In all honesty, I'm not the correct person to respond to that question, but if you can send it on that contact email list, I have a colleague, Peter, who is really well aware of all the legal aspects. I think that's better than me giving you an answer which is not complete.
Okay, thank you very much.
Yeah, you're welcome. Any other questions? But regarding the IPR, especially for the companies, I can see that this is a very important point. So even I will await this question on the email list, but I will already talk to Peter proactively to make sure that it's that in that call it's protected as it should be. So this is very valuable for me to be aware of this. So please, you can pose more detailed questions on the email list. But I thank you for raising the point, and we will make sure that it's protected as it needed to be, because I can imagine otherwise this is a big this could be a showstopper for that type of open call. So that's a very good remark. Yeah. Any other questions?
Just a comment, Wim, that it's a pity that the Genie Fed4FIRE week is after the deadline, the submission deadline of the proposal.
Yeah, I know. It's we are currently we have a review within a few weeks, and it's just from a practical point of view, it was not feasible to do it before that. Also, for the US people, they have to come outside of the academic year because they are giving lessons and so on. But I can imagine that it's a pity. But of course, for writing the proposal, like I said, you don't have to know all these fine details. But it would have been better. That's true. Also, we are currently we are also going to go into open access quite soon. But I think if you register now, so you have the documentation page, doc@fed4fire.eu. If you want to do these tutorials to just try out a few things, I think we have to look at that. We might be able to support you. So if you really want to try some hands-on things, just send me an email or an email to that contact list, and then we can see how we can give you temporarily access or so on. If you really want that hands-on experience. Anything else?
Yes, question. This is Walter Coliti speaking. You will probably say this later, but are there requirements for the use of the number of facilities? Like in the first open call, there was, I think, if I remember correctly, minimum 2 facilities had to be used. Is it still the same? I haven't seen this on the code page.
Yeah. So well, it's we never defined any minima. But what we did say before, and what we still see, what is still our position today, is we want to learn as much as we can from your experience. So we are about federation. So if you only use 1 testbed, we can learn less than if you use 2 or 3 or 4. So you will score on there are I think 7 or 8 criteria. You will score then a little bit less on one of them, because we can just learn if we have 2 proposals which are identically in all other aspects, but one of them uses 4 testbeds and the other uses 1. It's natural that the one which uses more will come out as a winner. But we don't have any hard requirements saying you have to use an X amount of testbeds. The only thing we would like to avoid, though, is that you make it artificially complex, just trying in an attempt to score more on this one criteria. So that's why we call it suitable size or something. I don't know by heart anymore. Meaning that we will look at the fact of just what is your problem, what have you considered as the testbeds that you want to use, and then we would say if we can very easily come up with 3 additional testbeds to use, which would be an added value for your case, then we say, well, you were a bit using too less. If on the other hand you have added 5 testbeds which actually mean nothing to your testbed, you will also lose points. So it has to be a natural fit of your problem to the amount of testbeds, and then we will see which one can give us the most information.
Okay, clear, thanks.
Okay. Anything else? Okay. In that case, please don't be shy or don't hesitate to contact us with any question you have on the email address. Just contact@fed4FIRE.eu. It's also on the website. We are very eager to help. We really want to have an impact as great as possible. We want to support all of you. So don't be shy. Big question, small question. Feel free to email us with anything else that might not be clear to you. Okay. In that case, I'd like to close the webinar. We will put this recording also on the website within today or tomorrow, I think, so that you can have a look at it afterwards. And then I look forward to receiving a lot of proposals for our open calls. Okay, thank you very much and have a good day. Bye-bye.
Bye.
Thank you. Bye.
Thank you. Bye-bye.
Bye.
Bye. Thanks.
Bye.